Hi, my name is Matt Duff. I'm an application engineer covering precision amplifiers, specifically instrumentation amplifiers. And today we're going to talk about doing multi-pole filter with passives, with just R's and C's. And what can we do with that? Alright, so if you remember, our single pole filter is just an R and a C like this. And it gives us a roll off like this where we're 20 dB per decade. And my cutoff frequency is at 0.707 or 3 dB down. Now, why isn't that good enough, or what's the problem there? Well, the issue is a lot of times we'd like something with a lot steeper roll-off than this 20 dB per decade. So let's say we've got some sort of interference signal there. And so ideally we want something more like what's called a brick wall filter, where I pass everything up to a certain point, and then after that I reject everything. And the only way to get something close to this brick wall filter is to use a bunch of poles. So how can we do multi-pole filter? Well, one thing we could do is we just add another R and C to our original single pole. So this is a dual pole filter. And down here at the very high frequencies, it'll work great. It'll give you a 40 dB per decade roll off. But the problem is that this section here is actually going to load down my original section. So before, when we had a single pole filter, we had this nice clean capacitor, and all it was a capacitor and gave us our perfect roll off. And now we've got this R and the C kind of in parallel with this C, and so now I start attenuating earlier than I'd really like because now I have some impedance here that's in parallel with this capacitance. So if I were to plot this compared to my brick wall, at this same cutoff frequency, this 1 over, our 1 over 2 pi RC frequency, now I'm going to have something around 1/3 of my original DC, or 9 dB attenuation. And that's not really good because I've got this whole area where I'd like to have my path band kind of high, and I'm attenuating a lot earlier than I'd like. So what can I do to fix this? Well, one thing I can do to fix this is make the impedance of my second stage a lot higher than the impedance of my first stage. So let's say I make this 10R and I make this C over 10. So I have the same cutoff frequency by changing it that way. But now this isn't going to load my first stage near as much because now the impedance looking into the stage is quite a bit higher. And you can kind of repeat that a few times. And this gives a reasonable, it's not perfect, but it reasonably doesn't load the previous stages. Now, the drawback of doing this is, of course, your output impedance gets higher and higher the more stages you add, and it's not, it's still not perfect. So, one thing you can do is you can add a buffer stage here. So I'm going to draw a little buffer stage. So we go back to our R and our C. And now this is completely buffered from my original stage. And now if I were to draw that much attenuation, what I'm gonna get is something more like this, where again, in both of these cases I'm 40 dB per decade. But at this cutoff frequency, this 1 over 2 pi RC frequency that I had before, now I'm only 6 dB down, or 1/2. So this still isn't wonderful, but it's better than it was before. And the reason that we're not, ideally we want 3 dB down or something even less than that. And the reason we're not there is what we're doing is we're combining, so this real filter that has 3 dB down at the cutoff frequency, plus another one that has another 3 dB. And if I were to combine more stages, each time it would add another 3 dB down and so forth. So you can see that just adding a bunch of these real poles together doesn't really get me to a point where I have this nice brick wall, because each time I add a pole I keep attenuating further and further down. So in order to get something closer to a brick wall filter, I'm going to have to use complex poles. And in the next session, we're going to talk about how to use a Sallen key filter to get complex poles.